Hello, welcome to our series on factoring. This is the beginning, factoring intro. We also have videos on factoring quadratics of trinomial arrangement in the forms x squared plus bx plus c and ax squared plus bx plus c, and the varying negative terms in those quadratics. We're going to start here because this is going to review the basic concept of what a factor is and the building blocks of those other types of factoring, factoring using the greatest common factor and factor using grouping. So just to remember, a factor is something that comes to us from multiplication, or I should say multiplication comes to us by factoring. The word factor, as you may remember from third grade, says the terms, in most cases up till now, the numbers that are being multiplied. So if we have that in a number and we are asked to factor the numbers, you may remember we did something that looked like this. We took, okay, give me two numbers that multiply to 12. Well, other than 1 times 12, so we'll say 6 times 2. Okay, so 6 and 2 are factors, as are 3 and 4. And of course, 1 and 12 itself. Actually, let me switch the 6 and the 2 so they're in numerical order on the left. So then after that, if I said factor completely, you would break the 6 down one more time into 3 and 2. So this, as you may remember, are the prime factors. So we have two different kinds of factors. We just have the basic pairs, what numbers together multiply to give us a certain number, and then we have the prime factorization, which are all of the numbers that you can't break them down any further, right? The only way to get 2 through a multiplication is 1 times 2. Same thing with the 5. 5 is already a prime number, so we cannot factor 5 anymore. The only factors it has are 1 and 5. Okay. So when we are looking for factors, why am I going through this in an algebra video? Because when we are going further into other expressions, we can factor them if those expressions have been constructed through multiplication. So that is pretty much all of your polynomials. So there's one other thing I want to review, which is greatest common factor. So this is, if I factor a number, what is the biggest factor that they share in common? Well, let's make a list. So for 5, we know the only factors of 5 are 1 and 5. For 15, we have 1 and 15, 3 and 5. So the greatest common factor here is 5, because that's the biggest number that we see in each of those two numbers. For 12 and 16, we would say 12 is 1 and 12, 2 and 6, 3 and 4. And I don't need to list the others, right? I don't need to say 4 and 3, 6 and 2, 12 and 1, because multiplication happens in any order we like. 16 is 1 and 16, 2 and 8, 4 and 4. And looking at these, I see the largest number in each of them that they share is 4. Remember, it's not the greatest factor, it's the greatest common factor. Now, if I was to have more numbers, I would just keep looking, for all 3 or 4 or 5, however many there were. Variables are different. Variables can be a little bit complicated. So looking at x to the third, I know that's x times x times x, and x to the fourth is x times x times x times x. The factor, in order to figure out GCF of variables, what I need to do is I need to look for what is the number of copies that they have together. So I can take all 3 copies of x from x to the third, because there are at least 3 copies of x in x to the fourth. So we would have x to the third as our greatest common factor here. For variables, different from the others, there is a shortcut. For variables, it is the lowest common exponent. So if we have a 4 and a 3, then it's 3. It's not the lowest common exponent. That can be confusing. The lowest exponent. So like I said, if I have a 4 and a 3, it's 3. If I have 3 and 5, it's 3. If I have 7 and 9, it's 7. Okay? So let's take a look at what this means for polynomials. So factor the expression here by finding the greatest common factor. There are two parts. I need a greatest common factor for my numbers, 4 and 12. So 4 has factors 1 and 4, 2 and 2. And then I have, for 12, I have 1 and 12, 2 and 6, 3 and 4. The greatest common factor of those is 4. For the variables, well, I just have an n squared. There's no other n, so I don't have any greatest common factor for n's because there's no partner for it. Okay, so we first find the greatest common factor, and we do that for numbers and variables separately. And then after that, we're going to divide the expression by the greatest common factor. So for that, I'm going to take my greatest common factor, which in this case is just 4, and I'm going to divide both terms, or all 3 or 4 or 5, however many terms I see, by that greatest common factor of 4. So with that, I'm going to have and again, when you factor, it's different. When you are asked to factor, your answer is a multiplication problem. So it's not just going to be a single number. It's going to be something that you could multiply to get you back negative 4n squared plus 12. So dividing, negative 4 divided by 4 is negative 1. I'm going to leave n squared because there was nothing else to do with n squared. And then I'm going to say 12 divided by 4 is 3. And then because it's a multiplication problem, I'm going to take what I divided by and put it back out front. And to check, if I multiplied this out, 4 times negative 1 is negative 4n squared, plus 4 times 3 is 12. That's exactly what I began with. So this is the factored form, 4 parentheses negative 1n squared plus 3. Okay, so that's factoring by GCF. Find the greatest common factor for the numbers, find the greatest common factor for the variables, divide, write your answer as the GCF times the remainders from that division, what's left after you divide. Now, with this, one other tip. You may have a situation where there is no GCF for the numbers or the variables. We saw that here with the variables. You may also have a situation where there is no GCF at all. This expression can be prime. You just have to make sure that you check all possibilities of factors before you say that. All right, practice this one on your own and hit play when you're done. The answer here is 6 times 5k plus 4. The numbers 30 and 24 have a greatest common factor of 6. There is only 1k in the problem, so I can't divide both terms by something to do with k, because that would not work out in the second term, because there's no k there to cancel it with. So I don't have a GCF for the variable. So I have 6. That's my GCF, times what's left when I divide. 30 divided by 6 is 5, k, plus 24 divided by 6 is 4. I can do this with terms that have polynomials that have more than 2 terms, of course. So first, for the numbers, I would take, in this case, negative 72, 9, and 90. So 72 has factors 1 and 72, 2 and 36, 3 and 24, 4 and 18, and then I have not 5, but I have 6 and 12, and not 7, but I have 8 and 9. For 9, I have 1 and 9, 3 and 3. For 90, and again, I'm not using the signs because those don't matter in terms of what our greatest common factor is. 1 and 90, 2 and 45, 3 and 30. And at this point, I know I got to look, to higher numbers because I have that 6 and 12 and that 8 and 9. But if you come across what you know to be the greatest common factor, you do get to stop. So we have not 4, but we do have 5 and 18. We do have 6 and 15. We do have not 7, not 8, 9, and 10. And I see that each of these has a 9 with it. So 9 is the greatest common factor of those 3 numbers. So I'm going to divide each of them by 9. I notice that each of them has a variable m. So the lowest exponent between m squared, and m to the 4th is the 1 from just m. So that's our greatest common factor for the variables. So 9m. I'm going to take that and I'm going to write it out front of some parentheses. And then after that, I'm going to do my division. So I'm going to take this, and negative 72 divided by 9 is negative 8. Subtracting 4 minus 1 is m to the 3rd, plus 9 divided by 9 is 1. Subtracting 1 from 2 is just 1m to the 1, minus 90 divided by 9 is 10. M's cancel. So I have 9m times negative 8m to the 3rd plus 1m to the 1 minus 10. Sometimes you can factor what's in the parentheses further. I'm telling you that this one is not one of those. Okay? So this one's a little bit more complicated, but you follow the same process. Greatest common factor of the numbers, greatest common factor of the variables, do your division. All right, why don't you pause and then we'll go over this one when you have an answer. So the answer here is 6k to the 5th times negative 9k to the 3rd plus 7k squared plus 6. The greatest common factor was 6k to the 5th because 6 is the greatest common factor of 54, 42, and 36. And then k to the 5th is the greatest common factor of k to the 8th, k to the 7th, and k to the 5th. All right, the last thing is this idea of factor by grouping. Factor by grouping is something of an add-on technique when you have 4 terms. Why 4? Why is that a thing? Because everything that we've looked at, we can factor anything by greatest common factor, any number of terms, 2, 3, 4, 5, whatever. But when we have 2 groups of 2, first 2 and last 2, it becomes easier to break that down when we split it into smaller chunks, right? So for the yellow set, we need to find the GCF of 56 and 49 to begin with. So 1 and 56, 2 and 28, not 3, 4 and 14. We have 5, not 6, 7, and 8. For 49, we have 1 and 49, not 2, not 3, not 4, not 5, not 6, but 7 times 7. So 7 is the greatest common factor between 56 and 49. Then we need the greatest common factor between a to the 3rd and a squared, and it is the lower of the two, a to the 2nd. Okay, and I like to finish with one group before I go on to another. So I'm going to do the division. 7a squared and divide. 56 divided by 7 is 8. 3 minus 2 is 1. Minus 49 divided by 7 is 7. A's cancel, close parentheses. Now, how do I know I did that correctly? Well, the GCF part, if you didn't do it correctly, you'll find out at the end, and I'll show you how that works. If you divided incorrectly, though, you would know right away also because you couldn't get back to what you started with. So let's just check mentally. 7a squared times 8a. 7 times 8 is 56. A squared times a is a to the third. Did that correctly. 7a squared times negative 7. 7 times 7 is 49. A squared times nothing is a squared. So we have negative 49a squared. I did that correctly. So then from there, I can proceed. I will tell you, and I will explain why later, we need to have a negative GCF here. But then I have to use the numbers 24 and 21. 24 has factors 1 and 24, 2 and 12, 3 and 8, 4 and 6. 21 has factors 1 and 21, 3 and 7. So then from there, I see the greatest common factor here is 3. So I'm going to divide those by negative 3. 21 doesn't have an a with it, so I can't take an a out where it isn't, so I don't divide by a. Drop in my GCF of negative 3, and then from there I'm going to divide. 24 divided by 3 is 8a, and then minus 7. Continuing on from there, now I have to do one more step. Now you might remember that when you do this, you might have gotten this before when you practiced or learned FOIL previous to this. You're going to take your two GCFs that you wrote, the 7a and the negative 3, 7a squared, and then minus 3. You're going to put those in parentheses. Now, one thing I did want to say here, again, I didn't go through it, but you can check if you did that second division carefully and correctly by just looking what I get, negative 24a plus 21, if I multiplied it, the blue part out, and I would. So the other thing that I did want to mention now is when you do this, and I said you would know if you had messed something up with your greatest common factors here, because notice that these two parentheses match. So they're both 8a minus 7. And so if that happens, you know that you are correct. You chose the correct GCFs. You divided correctly. The matching parentheses is the other part of your answer. So when you're doing this with 4 terms, or later we'll see it with trinomials in the next 2 videos, you should have a FOIL problem when you're done. The first parentheses are your GCFs, and the second one are your remainders, right? That's what 8a minus 7 is. You divided and what was left over. Okay, so that's how you factor by grouping. All right, you go ahead and try this one. And the answer here is 2b squared minus 5 times 5b plus 2. So again, I didn't make the list this time. The first two, 10b to the third and 4b squared, the GCF is 2b squared. And then I divided and I got 5b plus 2 as the remainder. The second one, I have 5 as my GCF, and it needs to be negative. Again, because we want to make the parentheses match, so when I'm done dividing, that first part of the remainder has to be positive. So I have to divide negative 25 by a negative number, that's negative 5. And I get 5b plus 2 again. Those two parentheses match, so I've done this correctly. The two GCFs go in one parentheses, 2b squared minus 5. And then my remainder is the other parentheses, 5b plus 2. Alright, thanks for watching. Make sure to check out our other 2 videos on factoring quadratics.